Once again, I would like to welcome. So the next point is state and prove pumping lemma for CFL. So basically, the pumping lemma which is used in context-free language as well as in regular language to show that the given language is not regular language or to show that the given language is not CFL. So basically, if you see here, the pumping lemma is used for visit more than one time a single state. Means we are visiting that state more than one time. So that is the nothing but the operation of pumping. We are going to pump that particular state. So let us consider initially we have x is equals to UVW, where phi is the substring causes to FA to start a state and return. Okay. So basically we are looking for, this is the pumping lemma. So if you see UVW, we are taking here three variables. So this is related to the regular language. It is not related to the context language. It is related to the regular language. Keep in mind this one. Okay. So the result x is equals to UVW is acceptable in all CFL instead of FA. Suppose derivation s is equals to phi az. Derivation s is equals to phi az. Now derive xay from a. We get s is equals to phi x ayz. Phi x ayz. So by substituting all these values, we got here s is equals to phi x ayz. Now derive in form a, we will give s is equals to vx ayz. So it is also written as phi x myz. Phi x myz are alphabets. Okay. If we derive a to n time, means if we proceed this for n time, then it will give us s tends to phi x raised to n my raised to n z. Okay. So we will get all grammars in s. So L of g is equal to vmz, phi xy mz, and so on, phi x raised to n my raised to n z. Okay, so that is the pumping operation. That is the original position of string. Then we pump for one time, then we pump for n time. So that is nothing but the pumping operation. The above derivation may give the ambiguity. It may remove, may cancel by using binary tree representation. Binary tree is having less than or equals to two child node, all the distance from single node to child, length, number of nodes, height of the path. So what that lemma says, you can see here, if the tree having height h with h is greater than or equals to 1, then number of leaf nodes is less than or equals to 2 raised to n minus 1. Now consider h is less than or equals to 1, we get leaf node is equals to 1. So by the principle of mathematical induction, whenever k is less than or equals to 1, you can say leaf node is equals to 1. Whenever k is greater than or equals to 1, you can say that maximum node 2 raised to k minus 1. So by proceeding this, you can see here this diagram which is helpful for pumping lemma. This one. Whenever k plus 1 is greater than or equals to 1, there are two possibilities. K is greater than or equals to 1, k is less than or equals to 1. It gives 2 raised to k minus 1, it gives 2 raised to k minus 1 again. By adding together, means 2 raised to k minus 1 plus 2 raised to k minus 1, which is equal to twice of 2 raised to k minus 1, which gives you 2 raised to k. Hence, we prove for leaves height k plus 1, number of nodes are 2 raised to k. Okay. So that is the example of pumping lemma. Yes, which is going to pump here C1, C2, C1 is going to pump C3, C4, C3 and C4 going to terminate at AB. Again, C2 pumps A and C5, A is going to pump with B and C6, C5 is terminating at A and likewise up to the AB. Okay, so that is the result. U is equals to VWXYZ. So that is the example for pumping lemma. Fine. Now take the next example. Next example is if L1 and L2 are context-free languages so that L1 intersection L2 is not CFL, then prove that L1 dash is not CFL. So basically two context-free languages L1 and L2 are given to you, and we have to prove that L1 intersection L2 is not context-free. So by the concept of pumping lemma, we know that a raised to I, b raised to j, c raised to k for I is less than equals to j and I is less than k is not a CFL. In the above example, stack allows to compare a to either C or B or C, not B and C at the same time. If we say S is equals to Wxy, if we say S is equals to Wxy, while consider W or Y is at least once we get S is equals to U W raised to 2 X Y raised to 2 Z if no single A is there. If single A is there, then you can write this as phi W raised to A X Y raised to A Z, and likewise it will be proceed till nth term. Okay. And likewise by solving, L1 will be a raised to I, b raised to j, c raised to k, where I is less than equals to j. L2 is equals to a raised to I, b raised to j, c raised to k, where I is less than k. Both are not CFL. Hence, if we consider projection form L1 and L2, as L1 gives S tends to ABC, A gives A tends to A capital AB, or null, B tends to BB or B, and C tends to C capital C null. It gives S tends to AC and A tends to AAC or B, B tends to BB or null, C tends to CC or C. Hence we can prove that this one is not going to follow that condition. Okay. Now again, if you proceed ahead, you have to apply the pumping lemma for a raised to n, a raised to I, b raised to I, c raised to I, where I is greater than or equals to 1. So we have to apply the pumping lemma for this a raised to I, b raised to I, c raised to I, where I is greater than or equals to 1. Let L be the CFL and I be the constant of the pumping lemma. So I is the constant. So if you see here, 0 raised to I, 1 raised to I, then c raised to I or 2 raised to I for I is greater than or equals to. Both having same meaning. Either you can take here ABC or you can take here 0, 1, 2. Z is equals to 0 raised to I, 1 raised to I and 2 raised to I. While Z is equals to UVWXY. We are considering here Z is equals to UVWXY, and most importantly you have to also mention here VWX is less than or equals to I and phi x is not equals to epsilon. Note that phi wx cannot involve both 0 and 2's. Since the last 0 and first 2 are separated by I plus 1 post, phi wx has no 2's. The vx consists of 0's and 1's having at least one of these symbols. Then uwy, which would have to be in L by PL, has 2's but fewer than 0's or fewer than I, 1's or both. It therefore doesn't belong to 1. Okay. So finally, what is the term here? So while applying pumping lemma for a raised to I, b raised to I, c raised to I, where I is greater than or equals to 1, simply you have to take this formula. Okay, so whatever previously we have discussed, you have to take this one and substitute z is equals to UVWXY by using these terminologies and going for the calculation. Then next question is what? Write a note on universal Turing machine. Already we have discussed during the our lectures what is meant by universal Turing machine. The machine which is going to the machine which having the properties of all the machines is called as a universal Turing machine. So you have to write down the definition of Turing machine. Basically the Turing machine which consists of 5 tuples, Q summation, then tape alphabet, Q naught and delta. So where Q is the finite set of states, summation is the input alphabet, then tape is the finite set of tape alphabet, Q naught is the initial state, and delta is the partial function. Okay, so that is the definition you have to write down. Then in the case of universal Turing machine, you have to draw this diagram. This diagram is very important. Universal Turing machine. You can see here. This diagram is already given by me. Universal Turing machine. 3 tapes are there. This is a T1, this is a T2, and this is a T3. T1 which is used for description of M, T2 which is used for tape content of M, and T3 which is used for stages. And for that we are using here encoding functions. In the case of alphabet encoding, A is encoded by 1, B is encoded by 11, C is encoded by 111, D is encoded by 4 times 1, Q1 is encoded by 1, Q2 by 11, Q3 by 111, and Q4 by 4 times 1. Move heads or movements are designed by left movement is encoded by 1 and right movement is encoded by 11. Okay, so basically for the equal we are using separator as a 0, or in between two alphabets or states or head we are using 0 as a separator. Now delta of Q1 comma A is equals to Q2 comma B comma L. How it may be encoded? So simply Q1 which is denoted by 1, so that is 1, then it is replaced by 0, it is separated by 0, then A is represented by 1, then equals to which is represented by or separated by 0. Okay, then Q2 which is 1 1 we have taken, then in between Q2 and B 0 is there, for B 1 is there. So that is the transition encoding in the case of universal Turing machine. When the question is asked in the Shivaji University Kolhapur universal Turing machine, then you have to write all these things, multi-tapes, these 3 tapes you have to write down, and whatever the discussion we have mentioned earlier, what is meant by universal Turing machine. Then you have to mention here Turing machine, tuples, then these are the things you have to mention. So that is the one example of Turing machine. So AB star, ABA, AB, ABA, AB star. So that is the example which is related to the Turing machine. How to convert the given finite state automata into Turing machine. So basically that is the finite state automata. There should not be any doubt for drawing the finite state automata. So AB star is covered over here, ABA is covered over here, ABA, and again this AB star will be covered over here. So how to convert this into the push down at, how to convert this into Turing machine. So basically before this initial state you have to add, you can see here, you have to add here Q naught as the initial state, and then use delta delta R, means by reading delta delta R it goes to the previously initial state, that is this one. Then you can see here BBR. So by reading B, writing B, it is moving towards the right side. Reading B, writing B, moving towards the right side. Then reading A, writing A, moving towards the right side. Reading B, writing B, moving towards the right side. Then reading A, writing A, moving towards the right side. Again one more thing you have to add over here. Here should not be halting acceptance. Here we have to take another state. Here should be, that should be the halting acceptance, and this should be that A comma B. So you can go with here A slash A comma R, and over here again B slash B comma R, and this will be your halting acceptance. Whatever the terms you want to mention, the halting acceptance will be this one. This one will be the halting acceptance. This is not halting acceptance previously mentioned. Okay, and as it is possible that if the string is not a part of this regular language, so in that case it will be going to the halting rejectance. So delta delta R towards the halting rejectance, delta delta R towards the halting rejectance. So what is the meaning of halting and what is the difference between halting and acceptance? As you know that in finite state automata and push down automata, accepting states was there, and from accepting state we can take any type of transition. But in the Turing machine we cannot take any transition after halting acceptance or halting rejectance. Both are accepting states, maybe halting acceptance or maybe halting rejectance. But once you reach to the halting acceptance, from that particular halting acceptance, you cannot take any transition. Okay, so that is the very basic example for the Turing machine. Then explain about combining Turing machine. So you have to write here definition of Turing machine, and already I have shared you among the what we can say in the classrooms. So write down all that definitions of combining of Turing machine. Okay. Then what is a regular language? Explain with the help of example. So regular language, you can see here, a regular language over the alphabet summation is an that can be obtained from basic language using operations of union, concatenation and clean. So that is the point from the first chapter, which is used from union, concatenation and clean. A regular language can be described by the explicit formula. It common to simplify formula slightly by leaving out set brackets. Set brackets are replaced by parentheses. Already we have seen that. Then union by plus. Okay. Then that result is called as a regular expression. Okay, so how to convert regular language into the regular expression? Simply curly braces are replaced by simple parentheses, union by plus, comma by plus. So that is the thing over here. Okay, so you can see here the set of R of regular language over summation corresponding to regular expression are defined as follows. So if phi is the element in regular language, then corresponding regular expression is phi. There is no issue. If null is the regular language, then corresponding regular expression is again null. For A belongs to summation, if A is the element of R, then corresponding regular expression is A. Very simple. Then the last one, if L1 and L2, these are the two languages, and R1 and R2, these are the corresponding regular expressions, then L1 union L2 will give you L1 plus R1 plus R2. L1 concatenate L2 will gives you R1 comma or R1 concatenate R2, and L1 star will gives you R1 star. Okay, so simply you can see in curly braces 001, that is the regular language, and which is converted into regular expression as 001. Again regular language is what? In curly braces 010 star, which is represented by in simple parenthesis 0. This comma is replaced by plus 10 bracket complete star, and so on. So simple thing is what? While converting regular language into the regular expression, you have to convert that curly braces by simple parenthesis, comma by union, union by plus, then clean star will be as it is. Okay, so these are the terms you have to take care while converting. If the question is asked, what is meant by regular language, explain with the help of example. So you have to write down all these things. Then the next point is what? Differentiate between DFA and NFA. File recursive definition of extended transition function delta star for NFA. So all these differences, you know that DFA, which is stand for deterministic finite state automata, which is stand for NFA, non-deterministic. There is only one state for the transition. No need of specify how does reacting to some symbols, that is NFA. Then cannot use empty symbol. NFA can use the empty symbol. Understood one machine at a time. Understood number of machines or multiple machines. Next possible state is distinctly set. Here next possible set is not distinct one. Then DFA is more difficult to construct, NFA is easier to construct. All DFA are NFA, all NFA are not DFA. So these are the differences. Then next one, reject string in case of terminals in state that different from the accepting state. Then reject string in the event that branch during the or refusing string. Time needed for the executing is less, is require more time. Require more space, it require less space. Dead state may be required, not required the dead state. And that is the last one is the transition function. Q into summation tends to Q. and here in the NFA q into summation 2 raised to q. So this is the simple diagram of DFA, this is the simple diagram of NFA. Keep in mind, this is very important. So then recursive definition of extended transition function delta star for NFA. So delta star, which is represented as, keep in mind this equation, delta star q into summation star tends to 2q, 2 raised to q. That is the extended transition function for delta star. You can see here, for any q belongs to q, delta star of q null, which is equals to q. Then for any q belongs to q, y belongs to summation star and is belongs to summation. Then delta star of y, delta star of qya, which is equals to union of r belongs to delta star qy delta of ra. So that is the extended transition function. While asking the question what is meant by deterministic finite state automata and non-deterministic finite state automata, you can list out all that definitions, all that differences. And in the case of extended transition function, you are just going to mention that star with these two terminologies, whatever discussed over here. These are the two terminologies. Be careful while writing this one. The next one, define NFA, write recursive definition of the extended transition function delta star for NFA with a null. So basically NFA is know that NFA is a non-deterministic finite state automata. Again, it is a 5 tuples q summation q naught a delta, but in the case of transition function, it is represented as q into summation tends to 2 raised to q. Okay, so keep in mind q into summation tends to 2 raised to q, which is for NFA, that is a non-deterministic finite state automata. So delta star for NFA with a null, a non-deterministic finite state automata abbreviated NFA as a 5 tuples. Yes, already I have mentioned. So these are the terminologies you have to mention here. That is very important. Q into summation tends to 2 raised to q. Recursive definition of delta star for the NFA with a null. So basically delta star, which is q into summation star 2 raised to q, which is for NFA, and additional to that you can see these terminologies. Earlier we have discussed this one. So these are the terminologies you have to mention over there. Then next one, write a CFG for syntax of programming language. So CFG for syntax of programming language, you can see here. In a C, one might try to formulate grammar rules by specifying what constitutes a legal statement. Two types of statement in C are if statements and for statement. If we represent abbreviatory statement by variable statement, the production involving statement might look like statement, if statement, for statement. The syntax of these two types of statement can be described by rules if statement, if expression statement. Okay, so that is the theoretical part you have to keep in mind. I am not going to tell that all these things. Now see the next question, write a CFG for x where n0 of x is not equals to n1 of x. Okay, very simple. So CFG, you have to write down the definition of CFG, that is a VTSP first of all. Then you have to take here three non-terminal symbol, yes, A, B. These are the three non-terminal symbol. Again you have taken two terminal symbol 0, 1. Yes is the starting symbol, and we have taken some productions. The first production is what? Yes tends to A or B, A tends to 0, 0A, 1AA, AA and A, 1A, and B tends to 1, 1B, 0, BB, BB 0 and B0B. So very simple, what we have to show here, n0 of x is not equals to n1 of x. So if you see the production which is started from A is totally different from the production started with B. So that is the CFG for n of x is not equals to n1 of x. Then next one, explain CFG and obtain grammar for language having equal number of zeros and 1. So basically while explaining CFG, that is a context free grammar which is a 4 tuple, you have to list out that 4 tuples v summation sp, and then grammar for language having equal number of zeros and 1. So basically if you see here, alpha tends to or A tends to alpha, where A is belongs to null and alpha is belongs to null, sorry, A is belongs to V, that is the A is belongs to non-terminal symbol, and alpha is belongs to non-terminal symbol union terminal symbol star. Okay, so that is the thing we have to put over here, that is in A tends to alpha. Element of V are called as a variables are non-terminal symbols, and those of alphabet summation are called as a terminal symbols or terminals. S is called as the starting symbol, and element of P is called as grammar rules or production. Okay, so that is very simple. Explain CFG, you have to explain CFG, and then you have to design the language for equal number of zeros and 1. The language generated by CFG, okay, the language generated by CFG is L of G is equals to X belongs to summation star, S tends to G star X. The language here is context free grammar, context free language if there is CFG, so that L of LG. Then next one, construct DPDA to accepting balanced string of parentheses. So basically what we have to do, we have to looking for DPDA, that is the deterministic push down automata for balanced parentheses, balanced string of parentheses. So this one is balanced opening and closing curly, opening rectangular, closing rectangular is again balanced. Let us consider one production, S tends to SS, then angular bracket, yes, closing angular, opening curly, yes, closing curly, and null. So that is the production given to you. Now we have to design the push down automata for that. So the move number will be what? Initially it will be at state Q0, it will be having input symbol null, okay, top of the stack will be Z0, so it will be going to the Q1 and opening curly Z0 will be there, means that opening curly will be pushed in the stack. Then Q0 rectangular bracket Z0, okay, so may possible that Q1 rectangular bracket Z0 will be there. Then next one, Q1 input symbol is opening curly, top of the stack let us consider previously again we had read the that particular opening curly, then it will be Q1 curly, okay. Then in case of Q1 input is rectangular bracket, top of the stack is opening curly, then it will be Q1 rectangular bracket and curly. And likewise if you see here, for Q1 input symbol is curly, stack symbol is a rectangular bracket, then it will be gives you Q1 curly rectangular. If both are rectangular, then it will gives you rectangular. So first six moves are for push operation. So we are using this for push, first 6 operation. Then if you see, whenever we are going to match, whenever we got closing curly at Q1 and top of the stack is what particular opening curly, then they will be get match, and then it will be remain at state Q1 and remove that one symbol, and it will be proceed up till whenever closing curly and opening curly is match. Likewise closing rectangular bracket and opening rectangular bracket, it will be perform and remove and mention that Q1 null. So once all the symbols from input head are read and all the symbol from the stack are got pushed, at that time one scenario will be there, input symbol will be null. So that is the scenario. So input symbol will be, state will be as it is Q1, input symbol will be here null, top of the stack will be Z0, and the result will be what? It will be Q0 Z0. Okay, means it will be going to the accepting state and top of the stack will be Z0. Okay, fine. So do one correction over here. Here should not be Q0, here should be Q2. Keep in mind, here is what? Q2. So that is the very simple example for DPDA of balanced string of brackets. Very simple. give your some logic so that you will be able to solve this one. This table is very important. Okay, not by heart this table, because first 6 are for pushing, then 7th and 8th for popping, and 9th for accepting. Then next one, concept of bottom-up parsing. So basically in the case of bottom-up parsing, what we are going to say this one as, it is called as a opposite to the top-down parsing. Okay, and reduce input symbol called as a reduction process. In the case of bottom-up parsing, start from the leaf node and going to the root node. Bottom-up parsing performing from the leaf node and going towards the root node. The production on which we apply reduction called production, that is T star F may reduce to F. T star F may be reduced to F. This process of reducing called as a handle parsing. We use rightmost derivation in reverse order. Fine. So types of leftmost or types of bottom-up parsing. Shift reduce is there. Simple LR parsing is there. Then canonical LR is there. Okay. Then look ahead LR is there. So examples are, if you see this example, this is the example given to you. So what is this? E tends to E plus T or T. T tends to T star F or F. F tends to ID. ID is the terminal symbol. For input string ID star ID. ID star ID. So what we can do? We can take here F star ID. Then we can take here T star ID. And then T star F. T, we know E tends to T, hence it is in E. Then on the right hand side, E tends to T. E tends to T is given. So this T is replaced by what? T star F. E tends to T, T star F. Then this F is replaced by ID. Then this T is replaced by F. And again F is replaced by ID. So we got here F tends to ID. So that is the right mode derivation. Very simple. Just go for one time practice, you will be get the idea. That is the bottom-up parsing. Describe the proof of union and concatenation of CFL is a CFL. So union and concatenation of CFL is CFL. Already we have discussed this one. So basically we have to take here two grammars, G1 and G2. In case of G1, VT V1 summation S1 P1. In case of G2, V2 summation S2 P2. And we have to show that it is going to accept the languages L1 and L2 respectively. And then for the union, you will be take here GU is equals to VU summation SU PU, and it will be generating L1 union L2. In the case of that, VU will be what? V1 union V2 union SU, and most importantly V1 intersection V2 will be phi. Then PU, so summation will be as it is, no issue. PU will be what? PU is equals to P1 union P2 union PU, where union SU, where SU tends to S1 or S2. That is the thing. Okay. And likewise, they have given L1 union L2, which is a subset of L of GU. Belongs to L of GU. So that is for union. And in the case of concatenation, very simple. So you can see here SU will be what? S1 or S2. Okay. So if you see here concatenation, this one concatenation, SC is equals to VC summation SC PC. Okay. So VC will gives you V1 union V2 union SC. Then PC will be what? P1 union P2 union SC tends to S1 S2. Whatever I am going to highlighting, that is very key points you have to write in the examination. So X is belongs to L1 L2, then X is equals to X1 X2, where X of I is belongs to L of I, and each I we may then derive X in SG as follows. So GC as follows. So SC is what? S1 S2, X1 X2. Again that H2 is replaced by X2, that is X1 dot X2, and finally it will gives you X, and hence you can write here it is going to SC going to S1 dot S2. So that is for union and concatenation. Then next question, construct a string copy Turing machine. So basically when the question is asked to construct the Turing machine, you have to write down what is the definition, formal definition of Turing machine. Whatever the question related to the Turing machine, you have to write down the definition of Turing machine. So Turing machine basically 5 tuples. There is also one MCQ in the examination paper. So keep in mind Turing machine is a 5 tuples. Okay, now what we have to do, construct a string copy Turing machine. So Turing machine to copy a string. So that is the starting state or initial state. So initially what will be happen? Delta will be read, delta will be write and moving towards the right side. Fine. And halting acceptance is over here. So may possible that there is nothing to copy. So at the very beginning it will be again read here delta 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 will be read, delta will be read, delta will be write and moving towards the left side, and it will be indicates that all the string is read, hence it will be delta delta yes. So this path q0 to this state, then this state and this state. So that is the very first for the copying Turing machine. And likewise this procedure will be for remaining one. Means what? Consider a specific string is given to you, then this direction will be followed. Okay, practice for 2 to 3 times and try to understand the logic, all of you. This diagram is very important. Turing machine of copy a string. Then Turing machine to delete the symbol. So this is the Turing machine for delete the symbol. So keep in mind this one also, this diagram. Then Turing machine for accepting n mod 2. Already I have given this for the university our CI examination. Then Turing machine for computing function for L for set of palindromes. So this is for set of palindromes. Keep in mind this example also. Even palindrome and odd palindrome also going to accept over here. Okay, copying Turing machine same as above in 49. Deleting Turing machine already we have discussed that one also. So these are the points we have discussed. So this is for, what is this? This is the difference between PDA and Turing machine. Definitely there will be difference between PDA or Turing machine, or the previously we have discussed what is meant by finite state automata and what is meant by non-deterministic finite state automata. So PDA which have one tape, Turing machine having infinite tape, it having stack, PDA having the stack, and it having infinite memory. It is less powerful, it is more powerful, accept CFL, accept all languages, possible input start left to right, processes input start in any order. Okay, it may be go towards the left side or towards the right side. Only memory accepts top of the stack. Okay, it can move tape head to the points on tape. Then halts when input is read, halts when accept and reset is reached. It going to going with type 2, it is going with type 1. It containing Turing machine containing 7 tuples, it containing 5 tuples. Make the correction, it containing the 5 tuples. Then this is the transition function for push down automata. This is the transition function for Turing machine. Okay, so these are the differences. Very important question, difference between PDA and Turing machine. You have to keep in mind and you have to solve this also. Fine. Then next question, construct a Turing machine for accepting reversing a string. So that is the question for reversing a string. So by heart this question and write in the examination. You can take the screenshot of this also later on. Okay. Then DPDA for string more A's than B's. So this is the question for DPDS string 1 more than A's B's. Okay. You can draw this one. 4 to 5 questions I am going to you people for the self study. You have to do that, which is related to the Turing machine, because it is very vast one, and if I want to explain a single point, then at least 2 hours of time is necessary in front of me, in the classroom, then and then it is possible. Otherwise I am going to sharing you the results, you can draw that. Okay. Then minimization of finite state automata, that is very important. Minimization, you can see here, minimization of DFA, we having two methods. First one is the transition table and second one is the partition method. While minimizing DFA, initial state of FA remain initial state and minimize the FA. Okay, we can combine accepting state together. Okay, so initial state will be remain as it is, accepting state can be combined together, or normal state together, but we cannot combine accepting state and normal state together. So that is the very first important point. We can combine accepting state together, we can combine normal state together, but we cannot combine accepting state with the other normal state, or accepting state, normal state, initial state with the other states. The state which are unreachable from initial state must be removed before proceeding. So that is very important. The state which is not reachable from the initial state, that has to be removed. That is the first one. Then remove all states that are unreachable from initial state via any set of transitions of DFA. So state which is not reachable from initial state, that has to be removed. Draw the transition table for all pair of states. Then what we have to do, after removing unreachable states, we have to draw the transition table. Not split the transition table into two tables, T1 and T2. T1 contains all final state and T2 contains non-final states. Then find similar rows from T1 such as delta of PA is equals to P, delta of RA is equals to R. That means find two states which have the same values of A and B and remove one of them. Okay, so let it be. You know that rules already we have discussed in the classroom. That is a partition method. So basically this diagram is given to you. So on this diagram you have to perform the minimization. So one is the initial state, 5 and 4, these are the two accepting state, and 2 and 3 are the normal state. So first of all you have to check whether all the states are reachable from initial state or not. Yes, absolutely, 1 is reachable from itself, 2 is reachable, 3 is reachable, 4 is also reachable, and 5 is also reachable. So there is no any isolate state. So all the states will be taken under the consideration. So if you see here, we have taken here 1, 2, 3, 4, 5. 1 is the initial state, and circles, these 4 and 5 are the accepting state while representing in the transition table. So if you see, once A transition which is goes to the 2, once B transition which is goes to the 4, and likewise we have taken all the transitions. Now as per the definition of partition of finite state automata, it is going to partitioning, that is a pi naught, which is containing non-accepting states, and another one is the accepting states. So which are the non-accepting state? 1, 2, 3, that is the non-accepting states, and accepting states are 4, 5, and let us say them as pi 01 and pi 02, and we have to check the behavior whether they are going to same state or not. So pi 01, so pi 01 is what? 1, 2, 3, and pi 02 is 4, 5. Now take the transitions of them. So if you going for pi 01, that is 1, 2, 3, so delta of 1a is equals to 2, delta of 2a is equals to 2, delta of 3 is equals to 1. So all are belongs to the same partition, no issue. Now checking for the another possibility, delta of 1b is equals to 4, delta of 2b is equals to 4, delta of 3b is equals to 5. They are also belongs to the same. So there is no splitting of 1, 2, 3. Then next one, there is no splitting for 1, 2 and 3. Now going for next one, delta of 4a which is going to pi 02, delta of 5a going to pi 02, and 4b and 5b also going to pi 02, means they having same behavior. And once you find out pi n and pi n minus 1 with the same result, you have to stop the partitions. So we can combine this 1, 2, 3 together, 4, 5 together, and that is nothing but the minimized finite state automata. So one suggestion to you people is that you should go through the question which is solved in the which was given by me in the CI examination, as well as one example I was solved in the classroom. That example should be taken by you people. Okay. The next question, write a note on PDA as a language acceptor. So language acceptor PDA, the first one, acceptance by the final state and acceptance by the empty stack. So when the given language is accepted by PDA, two possibilities. First one is acceptance by the final state and second one is the acceptance by the empty stack. So keep in mind this one also. Again the same question, state and prove the theorems union, intersection and complement of regular language. This is very simple, already we have seen. Then what is left recursion, that is theoretical part, you can go through that. So thank you so much for your patient listening. Already we have covered almost 60 questions which is from university point of view. So I am going to stop here lecture